Hey everyone! In this video, we're just going to keep going on a little further with probability. So let's recap what we've learned so far. So number one, we have in a class of 28 students, 14 have a cat and 13 have a dog. There are 9 students who have both a cat and a dog. Fill in the Venn diagram to help you with your answer. So the first thing I would start with when I'm creating my Venn diagram is the both category, that intersection. So students who have both a cat and a dog are 9, and that goes right inside here. Now, 14 of those students have a cat. So remember, that makes up this whole circle. So we already have 9 in there. So that means there's 5 students who own a cat but do not own a dog. Okay, because the whole circle has to add up to the 14. And then for the dog, same thing. If there's 13 students in the class that own a dog, then if there's 9 that have both, there are 4 who only have a dog. Okay, so now keep in mind that's a total of 18 students, 5 plus 9 plus 4. So we have 18 total, but the class size was out of 28. So remember, there's 10 students in this class that own neither a dog or a cat. Okay. So now that we have this picture, we can answer the following questions. What is the probability that a student chosen randomly from the class has a cat? So remember, you're choosing from the entire class, which is a total of 28. And we're choosing someone that has a cat, so that was a total of 14 for the cats. And if I wanted to, I can even simplify that down to 1/2, or 0.5, or 50%. You could write it really in any way you want. Now for part B, what is the probability that a student has both a cat and a dog? Now remember, this is called the intersection, okay, because it's asking us to do both categories. That key word is and, so it needs to have a cat and a dog. So that happened for 9 students out of the 28. And that can't be simplified, so we'll just leave it just like that. Finally, what is the probability that a student has either a cat or a dog? So remember, when you see or, that's the union. You're bringing everything together there within the sets. So what's nice about your Venn diagram is you've really already, by making this picture, have subtracted out the duplicates. So I could just take 5 plus 9 plus 4, and if I do that, I get 18 students out of the total in the class of 28, which can simplify to 9 over 14 if I wanted to. Okay? Or you could use the rule. So you could say the probability of having a cat, 14 over 28, plus having a dog, 13 out of 28, and subtract out the intersection. If you do that, we still end up with 18 over 28, and it would still simplify the same way. But the nice thing about having that Venn diagram, if you show your Venn diagram, you can use that for full credit. Okay, so let's look at number 2 here. We have John surveyed students in the high school about what technology devices they owned, and he found the following data in the table. And given this table, we want to talk about conditional probability now. So the probability that a student chosen owns a cell phone given she or he owns an MP3 player. So it's denoted like this. The probability of cell phone, this little line reads as given, but notice what the given is. She or he owns an MP3 player. So I'm saying for sure that they definitely own an MP3 player. So it's coming from this row now. And if it comes from this row, that means my total sample set is, my sample space has to be 70, right? Because that's what it's out of now. It's not randomly taking from everybody he surveyed, which would be the 102. It's specifically given that we already know they own an MP3 player. So from that category, we go in, and then the people that own a cell phone, there's 57 of them. So my probability is 57 over 70. Now, this can change because the probability that a randomly chosen person owns an MP3 player given she or he owns a cell phone. So now we're saying that they definitely own a cell phone. So this comes from this row here. So this row is a total of 80 students. So now that's my sample space because I'm picking from that 80 and I'm looking for somebody that has the same. And when I do that here, the cell phone and the MP3 meet at 57. So those are specific conditions that are placed. So let's kind of go a little further here and just kind of build our Venn diagram about this. So we know cell phone and MP3 meet at 57. So there's my intersection here. Now, my MP3 player, people, the total that they had an MP3 player was 70. So 70 subtract 57 gets me 13 people that only own an MP3. But look, that's what it says right here in the table. So using that, when I go in here, for 80 of my total, oops, sorry, I put that on the wrong side. 13 is going with the MP3. Now 80 with the cell phone, if I subtract the 57, I end up with 23, which is what is right here. So my table shows me everything. It's going to be out of a total of 102 students though, so don't forget the ones that have neither, that 9 is going to go right here. So this two-way table adds up to my 102 still, but we're just placing those conditions on it. But the Venn diagram would still look the same. But what connections do you notice between the numbers in the Venn diagram and the conditional probabilities that you calculated? Well, they both have the same intersection, but they only change based what the given is. Okay, so what I mean by that is in this rule, it's always, a conditional probability is always going to be both. So the intersection of A and B over the probability of what's given. So in this case, remember, it reads the probability of A given. That line means given. So that means that B is going on the bottom. So this could change, potentially. You could still have the probability, but B given A, and that would be equal to the probability of A and B again, the intersection of those two, but this time it would be out of the probability of A. So whatever the given is, that should be on the bottom of your fraction. And then because it's strictly out of that column, you have to use the intersection of both happening for the top. Okay? So we always want to make sure. And then if you have anything that's over 1, then we did something incorrect, because remember, probability is always between 0 and 1. But so let's go further with that idea in part E here. So I took the two things that we just got. They'll own a cell phone given they own an MP3 player. So that was 57 out of 70. And they'll own an MP3 player given they own a cell phone. So that's what we calculated in the first part. So the way I tell the difference here is just to do that in my calculator. 57 divided by 70, 57 divided by 80. Well, it looks like the first one's a little bit more likely here. Okay, so it's more likely that you'll own a cell phone given you own an MP3 player. Okay, and that should make sense because the intersection is the same for both, and like you're out of a smaller total number, so it's going to make a bigger probability. And let's just kind of follow up with that in number 3. So a survey was taken to examine the relationship between hair color and eye color. The chart below shows the proportion of people surveyed who fell into each category. If a person was picked at random, find each of the following conditional probabilities. Show the calculation you used. So for part A, find the probability that a person picked had brown eyes if they had blonde hair. So that if statement, that's the same as your given. So it's saying we know they already have blonde hair. So we go to the total of blonde. So 0.35 is our given. So that's the bottom. And then strictly out of this table, we want the people who have brown eyes from there. So that's 0.10. Okay. And I'm just going to divide that in my calculator. 0.10 divided by 0.35. And we'll put like 0.2857. We don't have to really worry about it. The nice thing about probabilities, they're not as specific. Usually the regions would have given you a place to round to, but probability, people don't really care too much. You could leave it just like that as well. Okay, now for the probability of a person had red hair if they had green eyes. So again, the if is your given in this case. So the green eyes total now. So the sample space, the total amount is only out of 0.25. So the given is always on the bottom. But we're saying red hair given they had the green eyes. So that's the 0.15. It's where the red hair falls within that row. And that was a nice one of 0.6. This conditional probability is that it's just as it sounds. There's a condition put in place. So given you know it's out of a certain group, whatever the given is or the if is, that's what the bottom of your fraction is. And then you only can pull from that category, so it's the intersection of it. Okay, so definitely use the pictures to